Welcome back to part two. In the last section, we ended off talking about estuaries, and we're going to talk about the material that actually makes up the estuaries. And that material is formed often into a thing called a delta, and you can see it here, and you can also see it here. All of this white material that looks almost like clouds, or the brown material here, is actually sediment that has been eroded upstream, carried downstream. Now remember, streams move by gravity, and so upstream they tend to be higher above sea level, thus moving more quickly than they are when they get down to almost exactly at sea level. Here is our third order stream. Remember, it's fresh, and then it's brackish, and then it's going to end up out in a saltwater body. And in this estuary, we looked at all of the plants and animals and farming and fishing that are able to be done there. Why is it able to be done there? Because it's not just sand and silt that's getting picked up, it's also minerals, and this mineral-rich items get washed downstream and then caught in these deltas. Now, an example of a delta is the Nile River Delta, and the Nile River Delta is extremely important to Egypt because without it, there wouldn't be enough nutrients in the very sandy soil that's naturally there to be able to support farming year to year to year. But what happens is that the Nile Delta floods over its banks or is dredged, and this nutrient-rich soil is placed on the banks where farmers use it year after year to be able to produce crops for Egypt. Deltas are formed by deposition. And here's an example of deposition where items are going to move by wind and they're going to get moved from one place and placed in another place. This is also deposition. These items have washed downstream. This is the faster eroding side of the stream. Here is the slower side. And what happens is that these items get deposited one at a time until the bank extends outwards into the channel of the stream. So deltas form this way. Oftentimes they start out small, and sometimes they can be returned back to this stage if a particularly severe hurricane comes in, and it can actually wash deltas away or drastically reduce deltas. Over time, more material deposits and more material deposits. This is how states like Louisiana's Butte portion are being formed. Erosion happens upstream, and here's a picture of that occurring. Do you see how all of this material, clearly it used to be flat, now it's an enormous void down into the earth? Things like the Grand Canyon were formed this way, and all of that material has to go somewhere. Here's an example of one that's formed by wind. And here's an example of where so much material eroded out from underneath the house that the house actually tipped over the edge of the cliff because there was no material underneath supporting it. This is obviously bad erosion. This is beautiful wind erosion. This little check is here for you. Hopefully from the last video and this video, you can identify the words estuary, delta, erosion, deposition, and tributary, and match them up to where they belong. There are certain characteristics that scientists measure to assess the health of a stream and to classify them. Number one, temperature. Generally speaking, animals like a cooler water system. The reason is that cooler water is able to hold on to more dissolved oxygen. The warmer the water, the less number of high quality species that are able to be found there. So in other words, if a stream becomes shallower and shallower, thus the temperature rises, sometimes the species will need to migrate or they'll go extinct in that particular body of water at all for two reasons. Number one, they literally can't breathe. There is literally not enough dissolved oxygen for them. And number two, sometimes things like algae tend to take over. Lethal conditions for trout. Trout really like cooler water. They have these optimal feeding temperatures. If it's nearer to freezing, they're not doing all that well. But if it's up here around 80, they're probably going to die. So we know that trout are a prime fishing or sport fishing fish in the state of Pennsylvania, and they really require Pennsylvania streams to have this very moderated 60 to 65 degree temperature. Temperature is affected by depth, sunlight, season, and how fast the water is able to be circulating. This is a moderately circulating stream. Current and velocity. That's pretty easy. Current is direction it moves. It moves by gravity. How steep that change is over a particularly given area tells you how fast it's going to move. This would have a much faster drop in elevation, and this would have a much slower drop in elevation. Thus, faster moving by gravity and slower. Current and velocity. The depth of the river matters. Rivers have the greatest velocity in the middle of the stream. The top and the bottom meet resistance from air and then from soil. So in literally the middle of the water column. Also, a smaller river allows for greater velocity. If you want to know why that is, that's Bernoulli's principle. You can look it up. Current and velocity. Some animals like a faster velocity, some animals like a lower velocity. So it's not exactly fair to say that faster is better. It just depends on the organism. Some things like to be able to attach to the bottom. Some things like to have a big, fast-moving water supply to move across their gills. It just depends. Substrate. Substrate is material that is suspended in water. This would have a fairly high substrate. This is an example of a tidal area. Well, this will end up getting covered back over, and you can see the sandy stuff that as that covering back over is going to occur, it might get sucked and moved up. When we can photograph shrimp this clearly, this one would have a very clear, very low amount of substrate. Abiotic substrate. This is going to be the non-living stuff. This abiotic substrate is so large, it's not able to hang in the water column. Sunlight. Is it there? Is it not there? And really the big deal with sunlight is that you have to have some of it so that plants can grow. But if you have so much that it warms the water column up to such a degree that a large number of animals can't survive there, then too much sun is not great. Like everything else in nature, moderation really rules the day. Turbidity. Low turbidity. Very clear water. High turbidity. Very mucky water. Imagine, this is what a stream looks like. Then the rain starts and the water starts to move. Then a flood starts. Even more erosion is happening upstream. Even more particles are being carried downstream. Generally, turbidity is bad. Animals like to have clear water so that they're not getting sediment and pollution into their gills. Here is an example of a lot of turbidity, and here is an example of a very limited amount of turbidity. These are questions that you can answer to hopefully make sure that you've understood what comes before and the answers. So, which river has a greater velocity? Hopefully you said A. Dissolved solids. Dissolved solids can be clear, like salt, or they can be dark, like dirt or silt. The dissolved solids are actually going to hang in the water column and be completely unable to settle out of the water column. Dissolved solids are measured in ppms or parts per million. Now, depending on the dissolved solid, it absolutely depends on where it's going to fall on this chart. But generally speaking, when we're talking about an outdoor surface water, a creek, a stream, or a river, We don't want a tremendous amount of dissolved solids, usually because they're going to be something like fertilizer or pesticide or mercury or arsenic. And so they do tend to be generally very hazardous in high quantities, both to human and to animal life. Up here is ideal. This is going to be filtered through the land. This is going to be aquifer kind of water. This is what your tap water tends to be, perfectly acceptable, perfectly healthy to drink. But much above that, and you start getting into areas where what is it that's being dissolved? Maybe up here it's something like fluoride, fine. Maybe down here it's something like lead, not so fine. Dissolved load, minerals, calcium, nitrogen, phosphorus, sodium, all types of things that can be dissolved into solution. Suspended load, that's going to be something that's a little bit bigger, usually makes the turbidity higher, things like clay. And then your larger bed load. This is going to be stuff that settles out, that is not actually capable of being held in the water column. Here is an example of bed load. There's actually going to be 2 videos after this PowerPoint that are going to show you what bed load looks like in fresh and in salt water. Here's a picture of salt water, here's a picture of fresh water, and you'll be able to watch those videos after viewing this presentation. Bed load. The current moves through the actual water. Depending on how heavy that current is, how much friction it has, depends on what kind of things can move. Bigger stones, smaller stones, only little tiny ones. All of this is going to move towards how much turbidity a particular body of water has. Which beaker has the greatest suspended load? Hint, it also has the greatest turbidity. Again, which one has a higher sediment load? The thing that has the greater velocity, greater erosion, and able to hold more things in suspension, thus higher sediment load. Now, let's identify all of these. 1, stream current. 2, load in solution or dissolved load. 3, load in suspension. 4, bed load. 5, stream bed. The bed load is able to move and bump and jostle, and as it moves its way downstream, this is what's going to end up depositing at the end of the stream, potentially in an estuary or delta. Dissolved gases. These are extremely important. Having an appropriate amount of carbon dioxide and oxygen are really important because obviously animals breathe them and plants breathe them. So hopefully you remember the carbon dioxide cycle where the plants take in the carbon dioxide and give out oxygen. This is what's contributing to having a healthy amount of dissolved gases in a moving body of water. Basically, the more advanced or the more sport-worthy the species, the greater amount of dissolved oxygen is needed. The simpler, the more common the object is, the less dissolved oxygen it needs. Generally speaking, the more dissolved oxygen, the higher the biodiversity, the less the dissolved oxygen, the lower the biodiversity. pH. This should be a review. We know that pH is the parts of hydrogen, low number acids, high number bases. Generally on a scale of 1 to 14, with 7 being neutral. Above 7, basic. Below 7, acidic. Remember, as we go away from the number 7, the object becomes stronger, whether it's a low number or a high number. Here are some characteristics of acids and bases that we've already covered. Generally, pHs in rivers like to be right around 7, maybe a tiny bit higher than that. Unfortunately, PA rivers have undergone acidification, and you should know that because when we talked about acid mine drainage, we covered that. Acid mine river, high turbidity, much healthier river after it's being cleaned up. Hope you enjoyed this. Make sure to check out the other YouTube videos that were included.